Hi, hello, my dears. Welcome to today's session on physical properties of matter. And this topic is most important and fundamental topic in physics in scoring examination like UPSC, NDA, Navy, Air Force, central test like CUT, NTS, examination like IIT, JEE, state examination like MSET, EPSET. Not only that, this chapter is also one of the important topic for NSET examination. Okay, let's start without wasting time. What is physical property? See, the word physical property means what? Matter is nothing but which has mass, which occupies space, that we call matter. Okay, just see first of all what is meant by physical property. See, the word physical properties are a physical property is a characteristic you can observe or measure. See, what is that? Without changing the substance identity. That means you are going to measure, you are going to observe a substance or material without changing its identity, and that we call physical property. For example, we are explaining in simple way by using of apple. If you want to describe an apple, as you know, it is red color and round and smooth. You are observing physical properties just by looking into the apple, but you are not changing its character, you are not changing its shape. Just you are observing, you are measuring some properties like color, size, shape, weight, and that we simply call physical properties. So this is, see how you know apple, how it's look like, you know very well. The smooth one, round and which attracting, and a fascinating fruit which attract everyone. See, look at this apple. Now the color and round shape, this smooth character, this smooth character, these all we call physical properties. Okay, like I see. What are the common properties? The common physical properties. Scientists use this ID cards to categorize everything on Earth. So what is that? The some uh, physical properties we have like mass, value, density, and so these are nothing but some physical properties like common properties. As you know, mass is nothing but container of an object, container of an object, and value is nothing but space. Density is nothing but mass by value. So just now as we discussed, what is matter? Matter is nothing but which occupies space, which has some mass, that we call matter. Matter at higher studies, at school level, we will consider matter has been classified into three types: solid, liquid, gas. But as of advanced studies, we define the matter into five types, that is solid, liquid, gas, plasma, and fifth form is about Bose-Einstein condensed form. So like that we have five different types of the matters. Some more physical properties like conductivity, malleability. As you know very well, what is conductivity? uh, Pass the heat or electricity. Metals, some metals, they able to pass the conductivity, they able to pass electricity, they able to pass heat, so that character we called as conductivity. Some metals, they are changed into sheet form. When we apply certain amount of pressure or force, the metals are converted into sheets form, and that we called as malleability. Metals are converted into thin wires, and that property we called as ductility. Ductility. So thin wire character is of the ductility. Sheet character is nothing but malleability. Apart from that, sonorous, lustrous, these are some of the physical properties related to matter. How do you classify these physical properties? Physical properties can be classified by two methods. One is called intensive, we call intrinsic. The other one is about the extensive, simply extrinsic. What are intensive or intrinsic properties? These do not depend on how much matter you have. Example, color. Example, color, density, melting point. A drop of gold has the same density as the gold bar. See, a drop of gold has same density as gold bar. That means gold bar density and small piece of the gold both are having same density. So this is about intrinsic property. They do not depend how much quantity, how much matter you have. Coming to extensive, we can also call intrinsic. These do change based on amount, mass, volume, and length. So based on some external characters, the properties will be changing, and that we call extrinsic properties. So here matter, just we discuss here, which has mass, which occupies space. My dear, look here, don't be bored. Just now we start. Which has mass, which occupies space, and that we simply call matter. Matter has been classified into five types. The first one is about the solid. In solid, particles are packed super close and they vibrate with fixed positions. They vibrate with fixed position. That's why solids have definite shape, a definite volume. Why solids have a definite shape and volume? The reason, they have packed with, the particles are packed closely, they vibrate fixed position, so that they have so strong, rigid, and they have finer shape and value. What are the physical properties of this solid we observe? It is having fixed shape, very high density compared to liquid and gases. Compressibility means reducing size by applying force. Real life examples. See here, that is ice cubes in fridge, they are in solid. Wooden desks, they are in solid. Diamond, one of the hardest material, that is in solid. Even the chair you are sitting on right now to watch this lecture, and that is also solid state. Coming to next one, liquid. Particles are still close, but they can move around and slide past each other. Previously fixed position. Here they have slide. The particles are sliding. They have definite volume, but they occupy container shape. Volume is definite value, but they occupy. For example, you take a glass, pour some water, whatever shape of the glass you have, the same glass shape will get the water. That is a container of shape. What are the properties of liquid? See, you can see that is they do no fixed shape, but they have a definite value, can flow and poured. So this flowing property we call fluid. Okay, now what are the real life examples? That is water, it is liquid, milk, mercury, and the cold drink what you are right now in the summer you prefer to drink that one because you like so much the cold drinks. So they are in liquid state. Coming to third one, particles are far apart, moving fast and randomly, and these particles they do not have proper shape and value. They don't have proper shape, they do not have proper value. They spread entire container. For example, you can take air, air is spread around you, is spread everywhere. So they do not have proper shape and volume, and the particles of the gas they move randomly. Coming to physical properties, expand to fill space, very low density, high compressibility. Compressibility is gas is greater than liquid, liquid is greater than solid. So this is about the compressibility character. Coming to density, reverse order. Solid is greater density than liquid. Liquid is greater density to gas. Look here, this is for compressibility, this is for density. Coming to your examples, that is the air you are breathing like oxygen and carbon dioxide, helium in potty balloons. So balloons are filled by helium gas because they are a lighter one. Steam coming out from a kettle. When we have the kettle during the winter season, we prefer to drink the hot coffee or tea, and from the kettle you will get the steam. Even from the rice cooker, after cooking the food, steam is releasing. Even the scent of your perfume, that's gas particle reaching your nose, they are in the gas states. Coming to fourth one, plasma, and this is advanced level material. The most common state in the universe, and that's about the fourth state of the matter, that's plasma. When you heat gases to extremely high temperature, so gases whenever they are heated extreme high temperature, electrons are repelled away from atom, creating soup of charged particles. For example, this is the gas particle, this gas container we are heating. Whenever heating these particles, the gas particles are getting into the steam character, and from there you will able to consider that is the form of the electron. These are create these gas particles for are creating electron sensation, and because of that one a charged cloud is formed, and that we simply call plasma. Or the properties, that is plasma state used for conducting electricity, respond to magnetic field, glows with light. So these are the plasma state character. Examples, lightning bolts in the thunderstorm, that is about the plasma. The sun and all the stars are producing basically radiation because of the plasma. Neon sign and fluorescent tubes, you are on the night time when on highways some direction signs you are able to see in colors which are indicating direction. They are nothing but fluorescent tube lights, fluorescent screen cards. These are nothing but plasma characters. Aurora means northern lights, they are in plasma states. Coming to last one, that's about the which one we call fifth matter, that is about the BAC. On our Indian scientist Satyendra Nath Bose. Satyendra Nath Bose is working with the Einstein. You know Einstein proposed a great equation E equal to mc square. He proposed relativity theory. He he experimentally verified photoelectric effect experiment and found that one, confirmed that one. Light is a particle nature. So that is about the Einstein. So that is the reason he received the Nobel Prize also. We know very well. So here the fifth form, that is the Bose-Einstein condensated matter. This is one the next level of the matter created in 1995. See, this is artificial one, not natural one. This is created in 1995 by scientists. You cool atoms to almost 0 degrees Celsius. That is absolute zero means Kelvin temperature. That is a minus 273 degrees Celsius. All the atoms start to act like a single superparticle. When atoms are cooled to absolute zero temperature or minus 273 degrees Celsius, that atoms start to act like a single superparticle that we call a quantum state, and this quantum state we call BEC. One of the properties, that is physical properties, particle lose individual identity. See, already you know atoms when they are cool, whatever, the atom will lose its properties. So it that means it loses its individual identity. Behave like a single wave. The group of atoms will behave like a single wave, just like a quantum state. And supervised quantum effects. Coming to real examples. Made in this is the matter we are, it is the artificial one. The first four about the natural one, these are about the artificial one. So here this BEC is created in artificial manner, made in special labs, used to create most precise atomic clocks, femtosecond, like that. We are using atomic clocks. For the purpose of atomic clocks, we are using this condensed matter. Scientists have even made superfluid that can climb walls. So generally fluid is flow from higher altitude to lower altitude, but some fluid they can move from low altitude to higher altitude, and that is because of the Bose-Einstein condensed state. So like that we have five different types of matters. So and few more concepts. Generally solid, upon heating it is converted to melting. Liquids, upon heating they are converted to evaporation, means the initial state, that is the boiling, at a gradual state that changes to evaporation. Then gas is changed to plasma state, that we called as ionization. Gas particles are converted to super cooled character, that is about the ionization. And the reverse with cooling compression. See, plasma to gas, that is called compression. Okay, these are all things we are related to physics. Sorry, they are related to physical properties of the characteristics of a substance that can be observed or measured without changing identity of substance. Just now we discussed here. These are essential for identifying materials and understanding how they will behave in different conditions. So here, what is the core concept? As just now we discussed previously, that is to understand their behavior, to utilize the matters in as per our need, we have to study physical properties. That's it. Physical properties will be mechanical properties, thermal properties, optical properties. Like that we have physical properties will be classified into mechanical, thermal, optical. Let's see what is mechanical properties. So here the mechanical properties like elasticity, plasticity, stress and strain, and from the stress and strain you will get Young modulus, bulk modulus, rigidity modulus. First of all, what is meant by elasticity? The ability of a body to resist a distorting disturbance influence, and return to its original size and shape when that influence or force is removed. For example, you can take this is just a duster what we are using in our classroom. Just you apply some force on the duster, then the duster deformed. Deformed means what? It is changed. Duster's shape will be changed. When you remove this external force, duster will gain its original shape, and that we called as elasticity. Next one is about the plasticity. The property of a material undergo permanent deformation. For example, you can take plastic ball. What when we are using for playing, just you squeeze your with your force, with your finger force, that plastic, like you can take the drink cold soft drink bottles or any drinking like Kindle water bottle. When we after drinking we are crushing that bottle, is it right? That bottle shape will be deformed, that we call permanent. Even though when you remove the external force, you won't get original shape of the blood. Okay, you are trying, but maximum to maximum you won't get 100% what before you are crushing, how it was. After removing the force, you won't get that exact shape. There will be little change in the shape. There will be a permanent deformation. That is about the plasticity. Coming to stress. What is stress? Stress and strain both are mechanical properties. First of all, stress means what? The internal restoring force acting per unit area, that is F by A. Force acting on unit area we call stress. When we apply force stress on some body, there will be change in the object shape that we called as the strain. The fractional change in dimension, what is that? In terms of length, volume and shape. So shape, volume or length, you are able to see some change based on this stress that we call strain. Under elastic condition, according to Hooks, according to whom? Sorry, according to Hooks, under elastic, under elastic condition, stress is proportional to strain. Stress is proportional to strain. Stress, when you remove this, when it is equal to strain, this is the question. Stress will be equal to strain when you multiply with a certain constant, that is called as K or constant. So that is K, Y or eta, any constant. For example, we are taking y equal to stress by stress by strain, and this y is known as Young modulus. What is that? Young modulus. The ratio of tensile stress to tensile strain is called Young modulus. It is represented by y. Coming to here, stress, just we discuss here, stress is nothing but force per area. Am I right? Force is nothing but mlt minus 2. Area is nothing but L square. So that you will get ml minus 1 T minus 2. This is about the dimension of stress. That is units what? That is F for Newton, A for meter square, Newton per meter square, which is nothing but Pascal. Am I right, my dears? This is about the stress dimension, this one. Coming to strain, it is change in length by original length, or change in volume by original volume, or change in area to original area, so that there is no dimension. See, length, volume, area. So strain, no units, no dimensions. Okay, clear? Okay, good. Coming to next one, that is about these are formulas. See what we have: stress formula, force by area; strain, delta L by L, which is about the dimensionless; modulus elasticity, stress by strain. We have three different modulus elasticities. Y is indicating Young modulus, B is indicating bulk modulus, and we can also call K, and eta is indicating rigidity modulus. Young modulus is only for solids, Bulk modulus for all materials like solid, liquid, and gas. Rigidity modulus only for shape, which is nothing but sharing. For change in shape, rigidity modulus. For change in volume of solid, liquid, gas, bulk modulus. For change in length, that is about the Young modulus. Steel, remember one note, steel is more elastic than rubber. Why? My dears? Yes, of course. It required more stress to produce same strength. Am I right? Steel is more elastic than rubber because steel require more stress to produce strength. This is the matter. Okay, coming to second property, that is the second physical property we call as thermal property. Okay, don't worry. After this, we will start the MCQs. Okay, but before that one, we need some basic concept. That is the reason I'm explaining. Don't worry, we will start the MCQs. Okay, here physical property. These related to how matter conducts, stores, and respond to heat. This is related to heat. Thermal means heat. Thermal expansion. What is thermal expansion? The tendency of matter to change its shape, area, and value. Area, shape, volume are changed based on the temperature, that we call as expansion. You can know, just you place a rod in the high flame, higher tendency of flame, the rod will be expand. Am I right, my dears? Okay. Sorry. Then coming to specific heat. What is specific heat definition? See, the amount of heat required to rise the temperature of one unit of mass by 1 degree Celsius. See, mass must be 1 gram and the temperature must be 1 degree Celsius. Then that we consider as specific heat. That is about 4.2 joule gram degrees Celsius. This is for the water. Okay, specific heat of water. Okay, specific heat is proportional to, specific heat is proportional, sorry, first of all, heat is proportional to change of temperature. Heat is proportional to mass, so that Q is proportional to, Q means what? Heat. M delta T. Delta T. Remove this proportionality, then Q will be equal to M delta T when you multiply with certain constant, that is called S, where S is nothing but specific heat constant. Okay, clear? So that is Q by M delta T. Q means joule gram degree Celsius. Next, thermal conductivity. The rate at which heat passes through a specified material, that we call thermal conductivity. Thermal properties, like we have the scaling. So this is the important thing you have to remember. Generally, C starting centigrade, that is introduced by degree Celsius. Sorry, the scientist name is Celsius. Celsius scale will be started by 0 and the number of degrees in Celsius scale is 100. Fahrenheit starting number is, Fahrenheit scale introduced by Fahrenheit. The starting number in Fahrenheit, what is that? 32, and the ending one is 212. The number of divisions in Fahrenheit is how much? 180. Similarly, Kelvin, the starting number is 273.1, maximum number is 373. There are 100 divisions are there. And finally, fourth one is Reamer. Starting number is, starting digit is 0, ending one is 80. So this is about start initial reading, number of divisions. Initial reading, number of divisions. Initial reading, number of divisions. So this is about the comparison between the scaling. Minus 40 degrees Celsius is equal to minus 40 degrees Fahrenheit. That means Fahrenheit scale will be equal to degree Celsius scale when at minus 40. Even though Fahrenheit will be equal to Kelvin around 574 value. You can check later. Okay, don't worry. Okay, next one, anomalous effects. What is anomalous behavior? What has maximum density and minimum value at 4 degrees Celsius? This allows aquatic life to survive in frozen life. So, fish, aquatic animals lives in the frozen lakes because of they possess maximum density at 4 degrees Celsius. So that is about the anomalous effect. So this is more so how the heat is transmitted. Heat can be transmitted conduction, convection, and radiation. What is conduction? Heat transfer in solids it is called as conduction, direct contact. Heat transmitted in solid that is called conduction. Convection, heat transmitted in fluids like gases and liquids that is about the convection. Heat transmitted without any support of the medium like electromagnetic waves that is about the radiation. What is that one? Radiation. So like that we have three modes of heat transfer: conduction, convection, radiation. Conduction is solid, convection it is in fluids. Fluid is nothing but solid, sorry, liquid and gas. Radiation without the use of the media, heat transmitted from, for example, sun rays. Without any medium, without any help, sun rays are falling on earth. Okay, next we go for the, okay, these are the representation. Three modes of the heat transformer. One is transfer, sorry, transfer. One is called radiation. See this flame during the winter season, we people prefer to take the heat sense, that is the radiation. And here we are, if it is a metal body, when we are touch here, you will get sense of heat when it is flaming. Then this is called conduction. After putting requiring, after giving requiring heat, then this liquid will be heated, then you will get the steam, and this we called as convection. Like that heat is transferred. Okay, the first question, sorry, without wasting time, we are going to quickly. Which of the following is a physical property of matter? See, the options are given: flammability, color, reactivity with the acids, and toxicity. So, as you know very well, color is a physical property. Color is a physical property. As just we discussed, color, shape, size, density, volume are what? They are the physical properties. So flammability, reactivity, toxicity, these are nothing but chemical properties. Physical properties can be observed or measured without changing the chemical composition of the substance. Color is observed directly. Example, blue flame, sorry, this is red flame, blue flame, while other involve chemicals. The other means what? Toxicity, reactivity, and flammability are known as chemical properties, but this color is physical property. Okay, don't worry, I will start complete quickly. Coming to second question, which physical property determine whether an object will float or sink in water? Okay, related to the sink and float. So here, mass, density, volume, and shape, we have four options. So here the correct answer for this one is about the density. As you know very well, this is river, this is ocean. When you are moving from river to ocean, your boat it is floated. Why? Because the density of the ocean water is more than river water. Reversely, when you are coming from ocean to river, your boat will be little sank. That is based on density. What is density? Density is nothing but mass by volume. Okay, clear? Density is mass by volume. Object with the density less than water. Okay, when it is float, when it is sink. Object, those who have less density, they will be float. Those who have more density, they will be sink. So which is having more density? See, water is, this iron is more density, this brick is more density, so that it is sink. And this wooden block is less density, so that is the reason it is floated. So the property is about density. Sorry, next, density is nothing but mass by volume. Coming to the third question, MCQ, the temperature at which solid change into liquid, when the solid change it to liquid. So here we have belt BP, sorry, we have boiling point, melting point, freezing point, and sublimation point. Sublimation is nothing but solid directly change it to gas state, that is called sublimation. Okay, now your answer is about the melting point. Melting point is a physical property where heat energy overcomes intermolecular forces without changing chemical identity. Ice is changed to water at 0 degrees Celsius. See, ice cube is converted to water. At what condition? At 0 degrees Celsius, that is called melting point. Then water is changed, this ice, what ice is changed to water, that is melting point. Water is changed to some heat, or sorry, temperature, some heat concept, or like before steaming condition, that is called boiling. Above the steaming condition is going to evaporate, that is called evaporation point. And solid is changed to liquid form, sorry, liquid is changed to solid form, that is called freezing point. So your answer is about the B, that is about the melting point. Sorry. Coming to fourth question, which state of matter has definite volume but no definite shape? So here solid will have definite shape and volume, then liquid will have only definite volume but no shape. So here liquids take the shape of their container but maintain fixed volume to moderate intermolecular force. So your answer is liquid. They have definite shape and volume, no shape, no volume, no shape, no volume. Here only definite volume but no shape. Coming to fifth one, so you can see liquid. See, they have container shape. Liquids, they have container shape. Solid, they have fixed shape. This is no proper shape, no proper value. That means they have possessing something. And electric conductivity. What is electric conductivity? See, the electrical conductivity is chemical property or physical or both. So your answer is, I know you are going to be both. Okay, sorry, that's not both. So here, electric conductivity is a physical property. It is measured by passing current through substance without altering its composition, like copper wire conduct electricity. So just look here. Electric conductivity is a physical property. That's it. Coming to here, see a physical property. Electron flow in the conductor, no flow in the insulator. So insulator do not conduct any electricity, conductor will conduct electricity. The material which are between conductors and insulator, they are called as the semiconductors. Question number 6, which property allows metals to be drawn into thin wires? See, we have in physical malleability and ductility. Malleability is nothing but sheet, ductility is nothing but wire concept. So here the property malleability is nothing but convert into the thin sheets, converting metals are converted into the sheets. And ductility is nothing but convert the material, converted, the metal is converted into the thin wires, that is called ductility. So your answer is ductility. Brittleness means breaking. Elasticity is nothing but after removing the force it coming to original shape, that is called elasticity. Ductility is a physical property enabling metals to be stretched into wires without breaking, like golds are stretched to the gold wires, that is about which we call ductility. Coming to here, ductility, see gold, it is gold bar, we have gold biscuits, okay. Then coming to question number 7, the ability of a substance to dissolve in a solvent. So solvent, we have solution, we have in solution we have solute as well as solvent. So solution is nothing but combination of these two things. So here what is ability? Dissolve in solvent. So dissolve in solvent, that is simply considered as not viscosity, not density, not conductivity, that is called solubility. Solubility is a physical property observed when sugar dissolve in water. Sugar dissolve in water without changing without a chemical reaction. That's about the question number 7. Coming to see here, sugar is dissolved, that is called solubility. Coming to question number 8, in which state of matter do particles have least kinetic energy? So here kinetic energy is Ke equal to 1 by 2 of mv square. So now here the answer is which is having least kinetic energy. So generally kinetic energy is proportional to absolute temperature, that is about the T. Now coming to this question, that is about in solid particle vibrate with fixed position, so they have minimum kinetic energy. See, That you simply understand that one, no fixed position, so they are randomly moving. So they now you can simply understand highest kinetic energy for the gases, next to liquids, least for the solid. So here your answer is least kinetic energy, that is about solid. So coming to ninth one, viscosity is the measure of liquid. So what is viscosity? Viscosity is nothing but it is the sticky character. Viscosity depends on, this is called viscous force. Viscous force the force in viscosity, that is called viscous force. Viscous force depends on the area of surface. Viscous force depends on the velocity gradient dv by dx. So F is proportional to A into dv by dx. Remove this proportional, then you will get F equal to eta A dv by dx. Now what is eta? Eta is nothing but our viscosity. So here viscosity is nothing but sticky character. The answer is resistance to flow. Resistance to Piezo, the units of viscosity. Okay, it is high viscosity liquids like honey flow slowly due to strong intermolecular force. Due to strong intermolecular force. Don't worry, I am going quick manner. Don't worry, I will complete in quick time. Okay, now you can see the figure. This is about the honey. Viscosity is a high, so that is the reason it moves slowly. Water viscosity is less, so it is moving fastly. See, you can see fast moving. Yeah, see, you can see, you are trying when you are eating this honey. When we are trying to hit, you are observe. It is like just like a long thread. You are able to see when you are pouring, when you are taking with a spoon. You are able to see this phenomena. This is slow movement, that is viscosity. Okay, now question number 10. Which of the following is not a physical property? See, water is nothing but smell. Hardness is nothing but stuff, means the strong character, taste. So now here the answer is water, hardness and taste are about the physical properties. Flammability is about the chemical property. Flammability involves a chemical reaction, while other flammable means what again? Flammable is nothing but burning substance. Okay, that is creating new substances. This, okay, order physical property, hardness is physical property, taste is physical property. See, you are taking honey taste, you are see your diamond which you are present to your girlfriend, which is very very brilliantness, which we have hardness. Coming to flammability, flammability is a chemical change. Okay, question number 11. Okay, I'm completing the process of liquid turning to the gas below its boiling point. Liquid is changed to the gas, and that simple one, your liquid is changed to the gas, that we call evaporation. Evaporation occurs at the surface at any temperature when high energy molecules escape into vapors. Water drying clothes. See, when you are drying the clothes, from the clothes the water is drying, that we call as the evaporation. So evaporation is a surface phenomena. So here this is not condition, means it is reverse order. That means solid liquid is changed to the solid, that is about the condensation. Freezing also same thing. Okay, now coming to the evaporation. Evaporation is a surface phenomena. Already you have surface. Coming question number 12. What is compressibility in ISO? What is compressibility reducing sign? Compressibility, just you can see the answer is gases. See, solids, liquids and same. No, this is gas have large intermolecular space, so they can easily compress. So you can see this figure. See, gases having large compressibility, then liquids, then solids. So highest compressible for the gases, then liquids, then solids. Coming to question number 13, transparency is a physical property related to water. What is transparency? Transparent materials allow light pass through clearly without scattering or absorption. Like clear glass, you can see glass. From the glass we are able to see other things, like in bakery we are able to see beautiful sweet material, or sweet beautiful eatable items through the glass, clear glass. From the showroom we are able to see beautiful clothes. That is nothing but transparency. Transparency is nothing but light transmission. It is all about light transmission. You can see here transparent See, this all about the opaque. Wood is nothing but opaque, which is not transport the light. Okay, you know very well. See, this is about the transparency manner. Coming question number 14, the temperature at which liquid becomes solid. At what temperature liquid is become to solid? So that we know very well. So here at freezing point is a physical temperature, physical property where temperature is changed to the where the material of liquid is changed to solid, that is called as the freezing point. So here same as melting point for the pure substance, that is about water at 0 degrees. So here liquid changes to solid, that is about the freezing point. Okay, clear? Coming to okay freezing point. See, temperature resetting as the temperature decrease the structure only. Okay, so this is about the so question number 15. Malleability allows a substance to be. What is malleability? Just previously we discussed about the ductility. Now malleability is a what is malleability allows a substance drawn into wires, hammer into sheets, broken easily, stretch elasticity. This is called elasticity. This is called brittlety, and this is brittle. This is about the ductility. So your answer is B, that is about the hammer into thin sheets. Malleability is a physical property allowing metals to be hammered or rolled into thin sheets without breaking, like aluminum foil, gold leaf, aluminum zomato, your food delivery. So that taking comes with the biryani. These all things are coming by aluminum foil wrapper. That's about the malleability. Coming to the okay, these are malleability hammer into the thin sheet. See, these are hammer into thin sheet like vapor, like sweet boxes. They have the aluminum or silver. Sweets are silver foil. On the sweet bakeries, you are able to see sweet houses. There is a layer of foil that is about the aluminum silver layer. Okay, now what is next one? 16th one. Diffusion is the fastest in where diffusion is high. Diffusion is nothing but what? When you use for spray perfume on your body, the person who those who are behind you, they will get more smell. That means gas molecules are transmitted from higher density to low density, and that we call as the diffusion. Here gases have maximum intermolecular space, high kinetic energy, allowing particles to spread rapidly. Particles, because they have maximum intermolecular space, maximum kinetic energy, that's why they spread rapidly, like perfume smell spreading quickly. So here your answer is diffusion fastest in gases. Gas after liquid, liquid after solid, least in solid. We are not able to see also, it is negligible property in solid. Now coming to the fastest gases. Gases are fastest, and solid phase sticky, liquid is this one. Okay, now coming to the 17th one. Surface tension is a property what? Surface tension is adhesive, gravitational, magnetic. Adhesive means stick, cohesive force of liquid. See, strong cohesive force between liquid molecules create a skin-like surface allowing small object to float. Small water float on water drops like bubbles floated on water surface. That is about the surface tension. Surface tension is about the cohesive force. This is adhesive, this is about the cohesive. Okay, this is coming to 18th one. Okay, if you have any doubt you can see here. This you know very well that mosquitoes are they are taking shelter on the slum, that is drainage system. Because of drainage system, the layer, it is the mud layer form more surface tension. That is the reason this this what we call this flies lays eggs, and they generating their next family. I see here this is about the fly, house flies, because this is about the surface tension, this is about the because surface tension is concept from cohesive forces. Okay, coming to the item one. Which state of matter has both fixed shape and fixed volume? So that is about the direct one. So that is about solid will have fixed shape and volume. Solids have strong intermolecular forces keeping particle in fixed position, giving definite volume and shape. Coming to C, solid fixed shape and volume, gas fill container, liquid fixed volume and take container shape. Coming to 19th one, thermal conductivity is the ability to, what is thermal conductivity? Transfer of electricity, this is called electric conductivity, dissolve in water solubility, melt at low temperature. So your answer is transfer of heat. It is the physical property of transferring heat energy through a material. That is called thermal conductivity. So coming to next 120, elasticity is what? Elasticity, just now we discussed in introduction. Elasticity is nothing but return to original shape. We have a duster. Upon duster, if you apply force, duster will be deformed after applying a force. After removing the force, duster will get its original shape, and that we called as the elastic nature, that we simply return to original shape after deformation. Elastic materials return to their original shape after being stretched or compressed after removing the force. Example, rubber band and string. Coming to 21st one, which physical properties allows separation of mixtures by filtration? So that is about particle size. So filtration separate based on differences in particle size. Larger insoluble particles are trapped while smaller ones are liquid pass. 22nd one, magnetism is a physical property primarily shown by. Magnetic will be shown iron, nickel, cobalt. Iron, nickel, not all metals, sorry. Iron, nickel, cobalt will show. They do not show. So here iron, nickel, cobalt. These ferromagnetic materials are strongly attracted to the magnet without any chemical change. So here the smell of substance is known as which property? Not chemical, not both. Definitely you are choosing both. The answer is physical property. Odor is detected when volatile molecules evaporate and reach nose. Biryani smell. That's about our perfume smell. That's about the physical property. Okay, sorry, I'm going to complete. Hardness is measured by a substance. Hardness is what? Resistant to scratching. Hardness is a physical property which is nothing but a resistant being scratched or dented, scratched or dented. So that is by, which is measured by Mohs scale. Diamond is the hardest material. So now the 25th one, final one. The boiling point of liquid is physical property affected by. How the boiling point is affected? The boiling point is affected by atmosphere pressure. That is about high action of pressure increases boiling point. High pressure, high boiling point. Water boils at a higher temperature in pressure cooker. Some extra questions. Let's see here. What is in Newton's, as per Newton's law, what is the dimensions of the this is called viscous force, this is called viscosity coefficient, area, this is called velocity gradient. My question is about what is velocity gradient. Velocity gradient is nothing but dv by dx. dv by meter per second, x is distance meter, so both will be cancelled. So your that is second universe. Am I right? Understood? Meter will be out. You will get 1 by s. 1 by s nothing but s inverse. So the dimension formula for the viscosity is m naught l naught t minus 1. Am I right? Once you check here, parallel layers of fluid moving at different speeds. So that is viscous force. Viscous force is nothing but this one. Viscous force depends on area, surface, velocity gradient. So dv by dx is the definition of shear strain stress measuring. Okay, so this is options are given. What options is given? Okay, sorry, just you look at here. A is wrong, B is wrong. Okay, that leave it. Just you focus on dv by dx. What is velocity? Velocity gradient is represented as m naught l naught t minus 1. I'm talking about the dimension here. Okay, sorry, just we go for the next one. Which type of energy is being absorbed by water at 100 degrees when it transforms? In water, whenever it is changed to the 100 degrees, which energy is absorbed? So that is the answer. When it is changed to that we call latent heat of vaporization. Water at 100 degrees, it is changed to the 100 degrees and the energy transformation is called latent heat of vaporization. What is latent heat of vapor? Energy to change liquid to gas at constant boiling temperature. That is called latent heat of vaporization. Thank you.